Hi, this is Phil. Um, if you've been following the development of the game Cybernet, you might be wondering how I'm coding all this. So in this video, I'm just going to go through how I've set up the main game loop, um, how I've used delta time to move things around that's sort of frame rate independent, um, so that things don't slow down when the frame rate drops. And also, I'm going to just go through how I've done the parallax scrolling of the background on the levels, and also how I've used the tiled map editor for creating the actual terrain, and also how I'm also using that for spawning enemies and placing various things around in the map. So first, if you have a look at my code here, if I just zoom out a bit, hopefully you can see that. So here's the main game loop. It's just a standard loop with a wait VBL at the end. Now, normally that'll run at 60 times a second, so that's how you get your 60 frames per second. Now, if you look at the top here, I've got these variables, so I'm just using the standard timer. I'm storing that in here, and then I'm calculating the delta time. So this basically gives me the time between when this bit of code executed and when it got to this line, set the last time, and then I'm using that to calculate the difference. So this will have a value in there, and that basically tells me how long it took to do one loop. I can then use that as a multiplier against values when I want to move things around on screen. So that's a global variable, and obviously throughout the code that can be used, and it's available. As you can see, there's not much in the main game loop. It's free go subs. So one there, as it states, that it updates the game objects, so that's everything: the player, the ships, the bullets. Um, so that looks after updating the positions and the states of those objects. The draw game objects, that puts everything on the screen basically. And then there's another one for checking the player health, so that looks after um, you know checking to see if the player's ship's destroyed, and it'll set various variables. You can see here that I've got a player state. I think that's a 0, 1 and 2. 2 actually means that it's game over. So if that occurs, then it'll jump out of this loop and go to another loop named game over, and that'll look after that bit. Level complete. So at the end of a level, obviously, this level complete gets set once the boss has been killed at the end of the level. So that's another sort of a trigger to jump out of this main loop and go to another area in the code. This little bit, key state 27, so key 27 is the escape key, so that looks after pausing the game. Again, it uses a goto to jump out of this loop, and goes into another loop to look after the game pause. And so all this, get rid of that. Every loop, it does these. And if you look at the go sub for update game objects, that's just below here. So there's many different things in there, so you can see the different things that it does. So it does these in order, so it'll update the map first, then it'll do the player, the ground enemies, the enemy ships, enemy bullets, and then collectibles. So that looks after updating the state of all those. And then you've got the draw game objects, and again there's a list there of all the different go subs that it'll do to draw everything on screen. So that's the way that I've set it up. There's probably many different ways to set up a main game loop. just keeps things simple. Obviously, there's more complex things going on in each one of these. What I'm going to talk about today is mainly the update map and draw map. So that basically gets the background scrolling and also the terrain scrolling. Now, just to mention, I'm not using any screen scroll commands whatsoever. I'm basically, maybe a bit of a trick, I don't know. It's just my approach, the way I've done it. I'm just basically drawing things at an offset, and I'll try and explain that best I can. So in terms of the backgrounds, if I just show you what I've got in the images folder. So each level has got it's got 4 images for the background, and if I just pull these into Paint, so these are the 4 images. You can see that they've got transparency. So once these are layered on top of each other, so that's the key background there, that's the main background. You can then obviously layer these on top of each other and the background will come through. Just to mention that the size of these images are the exact size of the screen that's set up here, the display width and height, so 1920 and 1080. And you can also see that I'm putting those size into variable. I could just use screen width and screen height there. I've just done it this way, it's just my preference really. So those 4 images, I'm drawing this onto the screen so that that'd fill the screen, and then I'll put that image on top of that one, put that one on top of that one, and then that one on top of that one. So they're layered basically. See? And obviously if I want to scroll those, all I'm doing is basically, if I put that on screen, if I do a paste bob and say the location, the coordinates are 0, 0, it'll fill the screen as it is. But if I say that I want to draw the bob at -10, then this will be offset and it'll draw it actually off screen. And you'd have a little gap at the side here. If you've drawn that -10 pixels to the left, you'd have a gap all the way down the right hand side there. So that's basically the trick. I'm just drawing these at an offset off to the left. And if I show you the code for that, I'll just show you these variables here, BG1, 2, 3 and 4, those are the actual image numbers. So if I showed you those for that level, you've got 492, 493, 494, 495, and you can also see that I've got another 4 there. They're actually for level 3, and there's 4 more there, I think they're for level 2. So as the level changes in the game, I just load those variables with those new image numbers. So the code that does the scrolling will just use the images that are assigned to those variables. Now these XB, XB1, XB2, XB3, those are basically the X position of each image. So as I'm making these negative, it'll move those to the left off the screen basically. So let me try and explain that a little bit using Paint. So let's say that this top left hand corner is position 0, 0, and this red area is the visible screen that you see. I've just extended this to be another 1920 pixels wide, just so I can show you this. So if I, in my code, straight at the start of the level, if we say that I'm going to put that background on screen, just put that in another layer so I can put that in. So that's what you'd see on screen. Then obviously as the level progresses, this gets scrolled off to the left. So if you imagine, you know, the X position starts going negative over here somewhere, this is the bit you see, and then on the right hand side you'd have this gap. So in my code what I do is I actually paste another one of these images at the end of this position there. So I'll just add another layer just to show you. So actually what's happening behind the scenes is that, so I'll paste one image there at a negative position, and then I basically add the screen width or the display width, which is 1920 pixels, and I paste another one there. And as this, you know, the X position keeps going to the left, both these images start going to the left. And then if you think on top of that, I've also got, you know, that image. So that'd go on top of that one. And I'd also put one of those on the end of there as well. And the same if we just do it again for that. Like that. So that scrolled to the left a little bit. And then you'd see that coming in there. So as these X positions, as these are getting pasted off screen to the left here, it gives you the impression that, you know, it's all scrolling. And basically all I'm doing is putting these at an off-screen position to the left. Now to get the parallel scrolling, these are just the X position of each image. Has just got different values to control the rate of how fast they move. So if you look at these, they're the variables that hold the X position of each layer, if you like. If we go to update map, there. So you can see here, these are the X positions of each of the 4 images, and this is where I'm using the delta time. So these are the values that are getting added to the current value. So -10 for the first image, -15, -28, -35. So the top image here is moving the fastest. So that's the foreground image. Because we're timesing it by, you know, that frame time that we mentioned earlier, that'd be a really small amount that's getting added to this. And obviously -10 would be even smaller than this one. So that's how you get the different speeds. Now, again, if you didn't have this delta time, if this was running on a slower machine that maybe ran at, let's say, 45 frames a second, it'd really slow down because you're not getting as many loops in that main loop. So that's basically how I'm doing the backgrounds. They're just getting a negative X position, and they're just getting moved off to the left off the screen. So if you remember how I said that I'm also pasting in a second copy of the same image off to the right. So all this area here would be, you know, off the screen. So I'll just show you the draw routine. If you have a look at the draw map here, and it's using these X positions. So you can see it's drawing the first image there, background 1, and then it's also doing a second paste of the same image, but it's adding the display width, which is the 1920. So that's how you get an extra image coming in there. And then what happens is once the image, see if I can find which one is it. Well, once this image goes all the way off to the left, it then basically resets back to 0. If we didn't do that, then we'd start seeing a gap coming in on the right hand side. And that's what these 4 lines do. So because these are negative values, I'm just using ABS to turn that to a positive. So it just gets rid of the negative part of the value, does ABS. So as soon as the value becomes greater than or equal to the display width, it just gets reset back to 0. So those 8 lines and those 8 lines basically do that. That's how you get the effect. So that's how you get these images going across. You can't see it, but there would be the second image coming in down here. If we could show you a line going down there for each one of the 4 images. There's actually 8 getting put on screen, although most of it's off to the right. And again, once that got down to 0, that's when the next it all reset and just loop back round. So to get those, there's actually 8 paste commands to get this effect. And the power of AOZ Studio, you can see that it's really smooth and it works really well. So that's the background. As you can see now, the foreground is coming in. You can see that coming in now. Now, in my code, I'm only drawing these are tiles, 64 by 64 pixels, and you can't see it off screen here, but these are getting, I'm basically drawing off screen the next column that's getting scrolled in, but that's as far as I go. I'm not drawing the whole thing, right to the end of the level and moving that to the left. Every frame, every one of these tiles is getting put on screen, which is, it's really fast. Obviously, what you could do is just open up a really large screen for the whole level, paste it all once, and then just scroll it to the left as you move through the level. But this is the way I've done it. I wasn't sure whether it was going to work. I was expecting some sort of slowdown or something like that, but to say that every single frame, each one of these 64 by 64 tiles is getting put on the screen, as well as the big 8 background images as well. It's really fast. Quite impressive that it works like that. So yeah, you can see in my folder structure here, I've got these files, level 1, 2, and 3. So these are the tiled files that get produced in the tiled software, which is this one. This is the tile software, and this is where I basically design the level. You can see there's no ships in here, no enemies. I've just cleared those out just for this video. So I've just created a testing map here just to play around with. And all this does, when you save this, it just saves out what's in each one of these cells based on these images that you create. So you create a tile set, import all your images, and they're assigned an ID. So if I click on one of these, you can see that that particular tile. It's got tile ID of 9. I've actually named that tile 519. So in my images folder, I've got an image called 519.png. So basically, when I come across, when I read this map in the code and I get an ID 9, I need to know that that's actually 519. Now, what I did was, when I loaded all these into here, I knew that I would have to do it like that. And so the ID of 0, which is actually ID 1, it's a bit confusing, but basically when I read this map position here, let's say, it'll come back as a 0, and if it is 0, then I know that there's nothing there. I don't need to draw anything. And when it's not 0, like a 4 for example, I basically add the difference to get to 514 in the images folder. So all these are all consecutive images, and you can see all the different bits, for the decorations and things like that. But again, sort of skipped over this a little bit, but I've got 6 layers in here. So the main terrain, I could turn that off. You can see all the decoration. So they're in a different layer. So I can turn those off as well. You can see it looks a bit plain. So these just make it look a little bit nicer. You can see these little platforms where I can put lasers and things like that. So one of the things that I said was that I'm not loading all this, the full level, into and putting it all on screen at once and scrolling it using the screen scroll commands. All I basically do is I've got a variable called level X that starts off at 0, and that's basically this position 0 there. And I know that to fill a screen with tiles, I think it's 32, 64 to get a full sort of set of columns of tiles. So in my draw code, I basically, all I'm interested in is the amount that will fit on screen plus one extra column, which I paste off screen to the right hand side. And then this variable that's keeping track of where we are in here, let's say that gets progressed each frame as well. So if that becomes 10, you can imagine on this particular square, which is 64 pixels wide, if it's 10, then what I'll do is that this first column, I'll draw it off screen at that offset of 10 pixels. So you'll only see on screen this area onwards up to where I've read up to the 32 columns. So let's say that X at some point gets increased to let's say 100 and I don't know 30. So that's 64, 128 plus another 2 pixels. So I'd actually be only interested in reading that amount of data or that amount of tiles. But that first tile would be drawn 2 pixels to the left of the screen boundary. And that's basically how I'm doing it. So as that variable increases, that tells me where I am in terms of which set of map tiles I need to read. And then depending on where it falls within the 64 tile space, if you like, um, on the actual physical or on the visible screen. It just gets either drawn off screen or dead on, depending on whereabouts it is. I hope that makes sense. So it's very similar to where that I'm doing the background. So it just gets, you can imagine that if this is your screen, your visible screen, I'm just drawing it off screen there, so it might actually start over here. And that gives the effect of it actually scrolling across the screen. Now, just to show you that I'm actually doing that, what I'll do, let's grab all the, just grab all these, just cut that out, just bring that a bit closer. I'll just save that. So here's the for next loop. So this is what we're talking about. It grabs 32 columns and the 16 rows. And so if I change this to only get 29, we should see on the right hand side it won't be drawing enough off screen. You should be able to see how it's doing it. You can see there how it's tripping over, grabbing the next tile, like that. And that's all based on this position here, the X position, the level X variable. So as it's tripping over into the next 64 cell, if you like, that's how it's grabbing the next lot of tiles to put on the end. Now obviously this is getting done but in the code, but it's getting done off screen to the right here, so you don't see this tripping over. And again, it's drawing these tiles even down here, it's putting these on screen every frame. And it's quite smooth. So in the draw map, you can see there's the background stuff, and then we'll just change this back. One, and you see these are the layers. So it's using the get tile value, or just to show you that when you save this out into the file here, this is all it does, just generates this file. So each layer has got this comma separated list of values. You can see these are the ID numbers of the actual tiles. So in the code in here, when I do the get tile value, these are values here that are coming back out into this variable, into the T string variable for that layer. Like I said, I've got 6 layers there. So the main terrain layer is this one, T string or T dollar. And so this is a piece of code here that looks at the X position. So that's the 0 to 31. So it times the X by 64 because that's the tile size. Then it takes off of that the level X mod 64. So that gets the remainder after dividing level X by 64. So that gives me the offset, the negative offset, to place the first tile, or to place the tile that it's actually putting on screen. So that's how you get, when we saw that effect where it's tripping over and pasting in the next tile, that's how that works there. So that's how that's doing that. The Y, that's just timesing that by 64. And then this is where I said about the values that are in here don't directly relate to a image number. I could have done it that way, but I'd already created images before I started on the terrain, so in hindsight it might have been better to do the terrain first. And if these could have, it'd have been easy if these matched the actual image numbers in the image folder, but it's no problem because they're all in order. All I need to do is add 509 to whatever values are in here. To whatever values these are, and they'll directly relate to these tile numbers here. So you can see there 547, 548. So that's what this piece of code does. And then a similar idea for the layers, for the decoration layers. That's what these two lines are for. And then you've also got, which I've not shown yet, but the ground enemies and the enemy ships, they're put on in the same way. Well, they're read from the map in the same way, but they're, because these are bobs and they move about and they're animated, they're not static. There's a function there, basically, or a procedure that takes in the actual tile value and looks after spawning that and adding that into the game, which I'm not going to go into in this video, but I will do another video of how I'm managing all the sprites and the animation and everything else. I'm not using AML, so yes, it's, again, I'll go into that in another video. Something else I didn't show you, there's also a layer that I've called commands. I've currently only got 2 commands. Zoom in here. Oops. Let's get rid of that. Yeah, so you can see some of these tiles, like these here. These represent ID numbers, so they're not actually sprites. But if you have a look at this one, play music, that's there. That's got an ID of 166 in here, and that actually comes out of the map as 167. So in this do command, you can see there, when that comes across a 167, it'll play the audio sample for the music for the level. So that there basically comes out of here, and it'll then do that sampler there. And there's also another command, end, which I'm using right at the end of the level. So as soon as it comes across that one, it'll basically set the map speed to 0, so it'll stop the terrain from scrolling. But the background will continue to scroll because that's a separate thing. This bit here will just continue. But that level X, which is the position that's being used in this nested for loop, because map speed will be 0, that'll actually stop changing. And that's basically what happens when you get to the boss at the end of the level. So it's just stops scrolling the foreground basically. you can see that in terms of the amount of code to actually get the background and the foreground moving and scrolling across, there's not much to it really. There's that, and then there's these that are using this get tile value, and then these here to put those tiles on the screen. There's obviously a lot more behind these two pieces of code. Just to mention, if I just show you this, if I put an enemy on screen or a ship enemy, I'll put a couple on. Because these are in the map constantly, if you think about it, if I read this here and tell it to add that to the game, I wouldn't want it to, in the next loop, to do that again. So luckily there's a set tile value command. So that'll basically, while I'm doing there, setting it to 0 so that in the next loop round here, it doesn't add the same enemy again. This doesn't change it in the file, that just does that in the, because these have been read into memory, so that just does that in memory. So I'm not changing the file at that point, which is good. It's good that it's got that set tile value, ideal for that. So you saw me just add those ships in there. If I play that, you'll see that magically you'll see those are actually on screen now there, look. All fully working. So I hope that's been helpful. I'm going to do another video that's going to go into the management of the sprites and all that sort of stuff. Hopefully I can explain that a little bit. Yeah, thanks for watching, and I'll see you again soon.